All right, geometry semester 2 exam review. I'm moving into chapter 9 problems. Chapter 9 has got all kinds of information in the middle column of our cheat sheet, from the Pythagorean Theorem to our special right triangle relationships, and then all of our trig functions and whatnot in the middle column of your cheat sheet. Make sure you're using it as you go along. In 3, 4, 5, and 6, this is straight up just Pythagorean theorem and then deciding if the value is a Pythagorean triple. In 3, I have a missing hypotenuse. 7 squared plus 11 squared is going to be equal to x squared. 7 squared is 49. 11 squared is 121. When I put together those, 121 plus 49, I get 170. When I take the square root of both sides, question is, do I have a whole number or an approximation? I get x is approximately 3.04. This is not a Pythagorean triple. My missing hypotenuse is 13.04, but it's not a Pythagorean triple. Number 4, missing hypotenuse again, 16 squared plus 30 squared is x squared. When I go into my calculator for 16 squared plus 30 squared, all together, that should give me 1156, the two together. When I take the square root of 1156, I get x is 34. It's exactly 34. So in this case, 16, 30, 34 is a Pythagorean triple, all whole numbers. Number 5, missing, let's see if I can fit it over here, missing hypotenuse again, 9 squared plus 40 squared equals x squared. 9 squared plus 40 squared, when I put it all together, I get 1681 is equal to x squared. If you did it in parts, great. Square root of 1681 is exactly 41. So that means then that 9, 40, 41 is a Pythagorean triple. Number 6, last but not least, 4 squared plus 6 squared equals x squared. 16 and 36 are my two squares there. That's going to be 52. When I take the square root of both sides, x is approximately, 52 is not a perfect square, x is approximately 7.21, not a PT. Now that's all section 9.1. When we go into section 9.2, this is all about 45, 45, 90 triangles. In 45, 45, 90 triangles, if we remember right here, there's 45, 45, 90. The side lengths are x, whatever the side length's value is. The hypotenuse is that value times the square root of 2. In number 3, we know one leg is 7. I know the other leg is 7. X is going to be 7 times the square root of 2. It's that simple. Now in number 4, we have a leg. If we want to get from a leg to here, we know that if we have to go from leg to hypotenuse, we have to multiply by square root of 2. But if I want to get from hypotenuse, if I want to get from a leg, if I want to get from a leg to hypotenuse, I multiply by the square root of 2. Here's one that I'm guessing some of you guys forgot. 5 square root of 2, get it over here, times square root 2. Square root 2 times square root 2 is going to be 2. The missing hypotenuse for number 4 is going to be 10. 5 times 2 is 10. Number 5, to get from the hypotenuse back to a leg, we divide by root 2. 3 root 2 divided by root 2 is going to mean that these legs are just 3. Not bad. Number 6, this one's a little bit different because we know we have to divide by root 2 to get back. So I've got x is going to be equal to 9 divided by the square root of 2. We have to rationalize the denominator. We can't leave a square root in a denominator. We get rid of it by multiplying by itself, top and bottom. So then this is going to be 9 square roots of 2. And again, square root 2 times square root 2 is 2. Missing legs on this one are 9 square roots of 2 over 2. You might want to look back at the stuff that we did in that chapter to help you, especially with these simplifying and making sure that you're rationalizing denominators. No square radicals can be left in the denominators. Number 7, we're still in section 9.2. This is our 30, 60, 90 triangle. With the 30, 60, 90 triangle, we like to start with the short leg across from the 30-degree angle. That's x. The hypotenuse is 2 times x. The long leg is x times the root of 3. Let's see what we have for each of these. In number 7, we're easy money. We start with the short leg. Y is going to be twice that. It's 18. X is going to be that value times the square root of 3. Nothing to do there, but leave those answers sitting. I have the long leg on number 8. This one looks like it could be bad, but actually to go from long to short, we have to divide by the square root of 3. So then x would be 3 root 3 divided by the square root of 3. Easy money. X is just 3. Now to get from short leg to hypotenuse, we double it. What's 2 times 3? We get 6. Number 9. Starting out with the long leg, I like to go from the, starting out with the hypotenuse. From the hypotenuse, I know it is twice the short leg, so if I divide by 2, short leg is 12. Once I know the short leg, I multiply short leg by the square root of 3, and that'll give me the long leg. X is 12 root 3. Number 10, we start out with the hypotenuse. This one's not so friendly. Well, it's not that bad either. If I want to go from the hypotenuse, I want to get back to short. Again, I'm going to divide by 2. So y is 12 root of 3 divided by 2. Y is going to be 6 roots of 3. 6 times the square root of 3. Those 12 over 2 can reduce to 6. Now, to get over to the long leg, I have to double that. 6 square roots of 3 times 2 is going to leave me with 12 square roots of 3. This was a pretty tough chapter, so take time to go back through your notes. Make sure that you're paying close attention to your highlights and your errors on your Chapter 9 test. Use your books, use your notes, ask for help. This trigonometry and this stuff is going to be a big component of your Algebra 2 next year, not to mention what is on your exam for geometry. Good luck.